Welcome back to another Visual Number Talk. This is Visual Number Talk number 12. It is a perfect way to introduce factored form versus expanded form for this kind of equation. And yes, it's related to a square. But let's get started by just talking about for each iteration, 1, 2, and 3, in the table, how many rhombuses do you see? Well, again, kids will begin by counting. In the first iteration, there are 4. In the second iteration, there are 9. In the third iteration, there are 16. And so if you begin to wonder about the fourth iteration, that's good. Let's talk about that. So how do you see the iteration number compared to the number of rhombuses? Well, I'm going to write the numbers here also. 4, 9, 16. These are perfect square numbers. 4 equals 2 squared, 9 equals 3 squared, 16 equals 4 squared. So many students will assume that here there should be 25 total rhombuses, which is also 5 squared. So it's going to be 5 by 5. Here we can already see it's 4 by 4. Here it's 3 by 3 and 2 by 2. Okay, so how do those numbers 2, 3, 4, and then 5 relate to the iteration number? So what your kids should hopefully be able to see or talk about is that this number 2, 3, 4, and 5 is always one more than the iteration number. So here we have x plus 1. 1 plus 1 is 2. Here we have x plus 1. 2 plus 1 is 3. Here we have x plus 1. 3 plus 1 is 4. And it continues here. We have x plus 1 because 4 plus 1 is 5. Now that's the length and the width, right? So to find the area of a square, it's length times width. So it's x plus 1 times x plus 1. So one way to write this equation, y equals x plus 1 times x plus 1. That's one way to write it. Now let's go back over here though and just fill in the rest of our table. So if the fourth iteration is 4 plus 1, 5 times 5, that's 25. And then the 15th iteration would be 16 squared is 256. And then the way you could write x, you could write x plus 1 times x plus 1. But a lot of students will also understand that this is the same thing. Repeated multiplication is using an exponent. So I could write this as x plus 1 squared. And so this equation could also be written as y equals x plus 1 all raised to the second power. Now, I did have some students that saw this in a different way, in the total expanded form way, which is cool. Check this out. I did have some students who saw this as the iteration number. So that's the x value plus 1. This is 1 plus x plus x. Well, so honestly, they saw this as the square because over here, they saw it as 2 by 2 plus 2 plus 2 plus 1. So let's do one more time, then I'll explain it. So here they saw 3 by 3, and then a group of 3, and then a group of 3, and plus 1. So plus 1 was the constant. And then the iteration number was being squared to make the square. So it was x squared plus these two parts plus 1. Now these two parts you can see are the iteration number. So it's x squared plus 2 of the x values plus 1. So like here in the fourth iteration, it will be 4 by 4, but then there's a strip of 4 here, a strip of 4 here, and then adding that one more here every time, the constant. So this right here, y equals x squared plus 2x plus 1 is the FOIL method of y equals x plus 1 squared. So this is a pretty cool way to see like the area model built in to the FOIL method to expanding a binomial. This all ties together, and you could also graph this equation and see that this comes out to the same as this. When you plug in the x value, it'll give you the same output, the y. If you've enjoyed this number talk, I have many more on my YouTube channel. Please like and follow for more. Also, check out superteacherguide.com. I have on there links to many other kinds of videos that I make for math. And also I will be teaching online next year, the 2024-2025 academic school year exclusively. So if you're interested, check out my link to my Outschool page. That's where my classes are. Thank you very much, and I will see you again soon.